Hi everyone! Last time we made this awesome RGB lamp over here and we were able to control it over WebREPL using Micropython. But today I want to build upon that and go one step further, be able to control this from your phone by running an asynchronous web server on the device itself. Now, for those of you who don't know, this is running in ESP32 with the latest Micropython build, which is 1.18 at this point. And what we're going to do is install the Microdot Python library, which is very similar to Flask if you use Flask in Python. And so if you're familiar with that, it makes it really easy to quickly add a web server and play around with things so that you can control your lights or your project using your phone, whether it be Android or iOS, instead of using commands from your WebREPL terminal on your laptop. So let's get right into it. I want you to go to github.com and Microdot by Miguel Grinberg. It's a fantastic library, and the library is just two source files. So just go into source files, you have microdot.py and microdot.asyncio.py. And we're going to need both of them because we're going to make an asynchronous web server so that it's compatible with all our crazy light patterns. So you want to download those and put them in your project folder. So here I have them, microdot.asyncio.py and microdot.py. Now, this is just in your project folder. We need to actually send it to the microcontroller. So if you see my last video, there is instructions on how to set up WebREPL and all that. So if you are confused about how to do that, please check out my last video. The link is here. In the meantime, I'm just going to connect to it. So that's the IP address of my particular ESP32. And I'm going to click connect. And I'm going to type in my password. And WebREPL is connected. So right now I want to send over those two files. That's what you want to do as well. You want to send your library files over to your project. So here, microdot.asyncio.py. It's 12 kilobytes. I'm going to click send to device. Okay, it's sent. That's awesome. And we're going to send over microdot.py. 32 kilobytes. Cool. Send it. All right, it's sent. So now those are on the device, so we can use them. Let's get into our code. So we're going to open up our Thonny editor. And this is the code I basically have from last time. We're going to expand upon it today so we can add our web server in. What we need to do first is, of course, import the libraries. Before we do that, I just want to quickly say this code is just on my computer right now. And every time we make changes, we want to try things out. Since I don't have my project connected via USB to my laptop, it's actually connected over the Wi-Fi. I'm going to be sending my new file over WebSockets or WebREPL every time, and we test out the code live by restarting the microcontroller. So let's get back to importing the library. So we're going to import uasyncio, and that's not the Microdot library. That's the asyncio library that's built into Micropython. And we actually do need that if we want to play and interact our LED patterns with the web server so that they don't clash and collide with each other. So I'll show you how to use that soon. And of course, we want to get the Microdot library, and specifically the asyncio compatible version of it. And we're going to import this Microdot object. And that object is basically the web server. It's a class that helps you use the web server. So let me increase the font size for you there. Fantastic. Okay, so this is our Neopixel setup from last time. I'm not going to change anything there. And these are the functions we have. So we have the ability to set an RGB color. We have the ability to convert an HSV or hue saturation value style color to RGB. And we have this pattern that I called Niagara. And it allows you to do these crazy rainbow fun animations. So I'm super excited to bring a web server to this. What we need to do is, before we try to set any colors or try to do any magic over the web, let's just do the very first thing that any program should do, which is hello world, right? Let's do our hello world. So let's make our web server basically respond to us with hello world when we go to the main page. So I'm going to call this section here set up web server. And what are we going to do? So we're going to create an instance of the Microdot application. And we're just going to create a route. So this is, you create routes in Microdot using Python decorators. It's exactly the same as Flask if you used Flask before. So this is going to decorate this function. I'm going to call that hello request. So it takes a request object. And we're not even going to look at the request object. We're just going to return hello world. Oh. Boom. That's it. So if you go to the IP address of this microcontroller, it should return you a web page that just has the words hello world on it. And we're going to try that out. And so before we do that, of course, we need to actually start the server. So let me define a function that lets you start the server. So we're going to call it start server, surprise, surprise. And I'm going to just say print starting Microdot app, just so we can track that from the web REPL console. And usually the code is just this. So app.run, and you supply a port number. The reason I'm supplying a port number is because the default port number is 5000, but I don't want to type in 5000 every time. If you use port 80, that's the default HTTP port, so you don't even need to put a port number in your browser. It'll just work, right? But think about this. What if I start the server? How would I stop it to do further development? How would I pause it? That's an important question, right? So let's have the ability to pause it by basically allowing us to press Control-C. So if you press Control-C, it kills the server. You can develop some more code, start the server again, right? So we're going to say, and this is just a little hacky Python trick, but basically this except clause here is catching any kind of exception, which includes keyboard interrupt, which is Control-C. So when you press Control-C, it gets an exception, it shuts down the app, and then you can play around with it and start again. So this will help us debug. Instead of having to constantly unplug and replug the device, we can just press Control-C and gain control of it again. So okay, this is it. This is everything. I hope it works. Let's send it over to the device. So I'm going to save that, and we're going to send it over just the same way as we've sent everything over. So we're going to choose file, choose main.py, and we're going to send to device. Okay, sent main.py 2068 bytes. Fantastic. Right now it is running a server, so I just hit Control-C there. And usually I would, in previous videos, do something like this to restart the machine. And I realize that is really tedious, right? Like, I'm pretty sure you don't enjoy writing all that every time you just want to restart it. And guess what? Luckily, there's a very simple way to do it. And I just learned this. You just press Control-D. That's it. Control-D, which is the end of file, which for some reason means reboot the microcontroller. And that's awesome. So I'm just going to go ahead and hit Control-D there. And I got disconnected. Of course I did. It switched off. Okay, so it comes back online pretty quickly. I'm going to hit connect, hit my password right there. Bam. Okay, we're in. This thing has stopped changing colors. It is stuck. Of course it's stuck because the server is dead, right? So let's import main, and we're going to do main.start. It has autocomplete. Fantastic. Main.start server. So let's hit that. Starting Microdot app. Okay, let's start it. Now we want that hello world. You don't actually have to use a browser for this. You can use curl, but you can use a browser. So you know what? Let's use a browser. Let's see what happens there. So let's go 192.168. I believe this is my server, right? Bam. Hello world. Oh my God. Okay, it worked. And the ESP32 can now talk to the world. Amazing. You can also do this using curl if you prefer command line because you're a very Linuxy person or something. So you can go HTTP. You can just curl that and you get hello world. Perfect. So there's two ways to test it. And of course you can do this from your phone as well, but I'll show you that at the end when we have all our patterns coded in. And it's going to be super awesome. All right. So next up, we are going to now expose one of the functions, right? So hello world is not very interesting. Let's expose set RGB so that we can control the color of RGB just by sending an HTTP request. So I'm going to create a new root called RGB, surprise, surprise. And we're going to say RGB request. And what we're going to do here, we are going to set RGB, of course, there, that, we just need to call that, right? So we need to take the parameters from the request and set them there. And these are going to be like get parameters. So just to kind of give an idea what I'm talking about, I'm going to put it in a comment here. Like someone's going to call this, so IP address /RGB. And you might have seen this if you use the web before. If you're used to APIs, you just do like a question mark to show that these are your query parameters. So R equals some number and G equals some other number and B equals yet another number. So this is what you're gonna have to type into your browser, or if you're using your apps, it'll be a bit easier than this. But this is a classic HTTP GET request. And here we can actually use that request object. So this request object is gonna contain a list of arguments, and those arguments are gonna be this R, G, and B value. So let's do that. I'm gonna leave that in there. All right. So we want to go set RGB, call this function up there basically, and you have to provide it a tuple or a tuple or a tuple of RGB values. So it's gonna look like that. And the thing about HTTP requests you have to realize is the values actually come in as strings. So we need to convert them to integers first, right? So we're gonna say int request.args R. And so on and so forth. So I'm just going to copy that. G and B. And let me just make sure our brackets are good. Perfect. Cool. We're going to do that. And with every request, whenever you use a web server, you should usually return something so that the client that made the request knows that, hey, everything was cool, the server didn't freak out. So I'm just going to return something simple, just return OK. Okay, cool. You have set RGB, right? So let's try that out. So what we're going to do is we're going to send one of these from curl, and we should, in theory, it should set the RGB to those 3 colors, and then it should return an OK, which we should see in our window. I'm going to save that. Now that our file is saved, we need to send it over web REPL. So we're gonna click choose file, and that's our new version of main.py. Make sure to click choose file again, even though it already says main.py there from last time. I'm pretty sure that's the old main.py. So do it again, send to device, send main.py. Fantastic. Okay, let's restart this thing. So hit Control D. Aha. Okay, so it's actually running the server right now. So hit Control C first to kill the server. And oh, disconnected. What's up? I'm gonna hit Control D. Now you see it comes back up pretty quickly. I like that. All right, and so we're gonna start the server. This time we're gonna test out if our RGB works. Cool. So let's hop into a terminal again and use curl. So this time we're gonna say RGB. R equals, let's just try setting it to red. So 255 and G equals 0 and B equals 0. Cool. Hit that. Oh, okay. Yeah, I saw that out of the corner of my eye. Fantastic. It works. Okay, cool. So that's taken care of. So we have a working server. It serves RGB requests and it gives you a little hello world. Let's take it up a notch. Let's do hue saturation value. So what we're going to do there is basically the same. So I'm just going to quickly bang out the logic for that. So we want a new route called HSV. Make sure to put the leading slash there. And I'm going to call it HSV. And honestly, let's just copy that code because it's almost the same. With a slight difference, of course, we're going to call a different function. So the example there, I really want to be able to say HSV equals H saturation and value. H actually can go all the way up to 65,535, right? So let's just put in a bigger number here just to make it very clear what's going on. So instead of setting RGB directly, we're actually going to convert the input parameters into HSV first using this function up here. It takes a hue saturation value, converts it to RGB, and then spits it out. And Actually, I think that's it. That's the entire function right there. Yeah, let's try that. Send it over, choose file, main.py. Let me connect there. I'm not sure why it disconnected. Okay, it's sent to device. Okay, and hit Control D over here to restart that device. Connect again. All right, run the server. At this point, I'm pretty confident in the server, but I still do like the ability to run it from here. But eventually, when we're done, we're just gonna start the server automatically on boot up, so that we don't have to keep hitting main.start server. So let's do that. Starting Microdot app. Awesome. Let's curl it with a new request. So instead of RGB, we're gonna do H equals. Let's do my favorite color, which is a very nice minty color, and saturation equals full, and brightness, just so that I don't blind you, I'm just going to turn it down to maybe around 100. Go. Internal server error. Aha! I forgot to change this to HSV. Internal server error again. Okay, what's up? It doesn't like it. Why is that? HSV. Did I do something wrong here? App.root HSV. Aha! The code is wrong. Who would have thought? Copy pasting things results in probably 90% of errors, doesn't it? Alright, let's try that again. So I'm gonna kill the server, Control C. Send over the new file. So this is actually awesome. Like, I'm sending over new code, like over the air update, and not having to like flash it and compile it and all that like I would have to do in Arduino. So honestly, this is really fast. Okay, cool. Import main.start server. Let's go. Let's try our previous minty color again. Yes. Fresh, minty fresh. Okay, great. So that's all the basics. So you can already use this web server. You can change colors. You can do all this just from simple HTTP like API commands, which is great. Now I want to bring on something much more complicated, which is that Niagara Falls kind of animation and all the parameters it has. So that animation, the difference between that one and this one, for example, with this one, we just send one value to the Neopixels, and then that's it. The code stops interacting with the Neopixels. Whereas for the Niagara Falls one, there's every few milliseconds, it needs to send a new pattern, right? And what's gonna happen is, if you try to do this the normal way, so by normal I mean synchronous, so you send a request to the web server, hey, start the Niagara Falls animation, and if I just ran the Niagara Falls function, it would block the whole microcontroller. So the microcontroller's entire scheduler, like time and resources, would just be spent on sending new patterns, new color patterns, and the web server would not be able to take any more requests from me anymore, right? What we want to be able to do is we send a pattern, and then the web server is still running, and they're coexisting side by side, and that's where the asynchronous comes in. So if you've worked with JavaScript before, you might already know how to think like that, but in Python, it's not very intuitive necessarily. So I'm going to explain how asynchronous works by running this web server. So what we need to do is, first of all, you notice that the function setNiagara is a normal synchronous function. When you use the library async.io, you actually get new keywords, async and await, that allow you to tell the interpreter that this function is asynchronous, right? And it's very simple. You just go asynchronous function Niagara. And why do we need to do that? Basically, we need to do that so that this time.sleep down here, this is the part where we can get asynchronous. This is the part where we can say, instead of doing time.sleep and blocking the microcontroller, what we're going to do is, in this point, we allow other stuff to run. So we're going to allow the web server to run right here, so that while this function sleeps, other functions can do stuff. And the way to do that is actually very simple. You go uasyncio.sleep milliseconds, and you need the await keyword right there. What does this mean? This means wait till we sleep for these many milliseconds, you know, and by wait, I mean go do something else. Like go do whatever you want, run a web server or run some other function. And then once this few milliseconds have passed, come back here and then run this loop again. That's what we're doing. So we're really just saying like, forget about me for like 50 milliseconds. Don't worry about it, you know? That's what we're saying. In order to use that down here, we also need an asynchronous call to it. So I'm gonna make a new root. I'm gonna call it Niagara. And we are gonna take in our request and do something similar as before. So I'm gonna be much more careful copy pasting this time. What we want is IP address, and then over here it'll say Niagara, and these parameters are all totally different, right? So a couple of things here. We don't actually want the user to have to set all the parameters every time, because we have defaults, right? Like we have a default saturation, default value, default of everything. Actually, let me go change that to something faster and smoother. 10 milliseconds, let's say. You have a default hue gap and hue cycle speed. So really, if I wanted to just say HTTP IP address /Niagara, I could do that. And how are we going to do that? So basically, we need to treat these optional parameters separately. So let's try to start by grabbing those. So here, just as an example, I can set the saturation, but just gonna put in there all params are optional. Okay, so how do we do that? We're gonna create a dictionary of arguments. So args dictionary equals, the reason I'm doing this is because, so the request.args is technically a dictionary, but all its values are strings, not numbers, right? And actually, it's not even really a Python dictionary. It's like a separate class called multidict. So I just want to avoid all that and just bring it into like a normal Python dictionary. So we're going to go for key in request.args.keys. So for every key, such as sat, val, hue, delay, cycle, whatever, like all those keys, we're going to say, we're going to just put it in our dictionary. So argsdict key equals request.args key. And with the only difference being, of course, that we need to convert that to an integer. Okay? So we're going to say integer of that. So for example, you get saturation equals 230 in quotes, like a string. This will just put saturation equals 230 into this dictionary. And why am I putting in a dictionary though, right? This function doesn't take a dictionary. So this is where some really cool Python syntax comes in. It's similar to the spread syntax in JavaScript, where basically you can take a dictionary and spread it as the function parameters using asterisk. And I'll show you that. It's pretty simple. So we're gonna say, this is where it gets very asynchronous. So create task. So when you have an asynchronous function, basically something like that, you don't call it directly. You don't just say set Niagara. You want it to be called asynchronously, right? So you're creating a task so that it gets called by the scheduler, and the task is set Niagara, and this is where we're gonna put in our args dictionary, right? But again, like I said, it doesn't take a dictionary, so you need to use asterisk syntax to convert that dictionary into a list of keyword arguments. So it'll look like this, and that's all there is to it. It'll work. And we of course want to return okay, right? Lastly, don't forget to define this as an asynchronous callback. So yeah, as soon as the user goes there, it's gonna get this request. We're gonna convert all the parameters in the request to integers, and then we're gonna call the set Niagara function using uasyncio.createTask, so that it's called asynchronously, and return okay. This is almost good. There's one problem with this, but I would rather show you the problem than try to do this. So I wonder if you can guess. I wonder if you can guess what the issue is. All right, let's try it out. Let's go to our web repo. I'm gonna Control C to stop the server there. Aha, sent to device. Okay, it's sent. So I'm gonna Control D to restart it. All right, import main, start server. Let's go. Okay, moment of truth. So we're gonna this time curl a Niagara request. And let's just do the default Niagara request. Like, we don't have to worry about the parameters too much for now. Or actually, I'm gonna set the brightness low just so I don't blind the screen, the camera. Okay, that's fantastic. Look at that. Okay, it works, right? It works. Right. Okay, let's try. What if I wanted to change the brightness? Oh, seizure alert. Okay, gotta stop the server. Control C. Okay, I've lost it. Okay, I'm gonna go unplug it. Phew, okay, it's off. Cool. What happened there? Basically what happened is this. I'll show you in the code. This line right here, uasyncio.create task. We're creating a task to set the Niagara LED pattern, right? Which is great. And then it goes off and asynchronously does its thing and like changes the colors. Now, when I go hit this root again, so if I want to say change the brightness or change some parameter, it creates another task. So it's actually running two set Niagaras in parallel. And this is kind of where like you need to be careful with concurrent programming like this, right? What we need to be able to do is every time a new request comes in, we want to delete the previous task, right? We don't want two set Niagaras running at the same time. And so the way to do that is fairly straightforward. We need to just track the current task. So I'm going to create a variable called current task, and that is for now none. And the Microdot library is actually pretty cool. It allows us to apply a certain function to every request that comes in. And basically what we want is, we want a function that takes every request and kills all current tasks, or kills the one current task before servicing that request. And for that, we have a decorator called app.beforeRequest, which is very well named in my opinion. And this is going to be an async function, and I'm just going to call it pre-request handler, even though we're never going to call that function ourselves. So yeah, whenever we get an HTTP request, if there is a current task, then we're going to do current task dot cancel. And cancel is again something from the asyncio library. So just how we have a create task, we also have a cancel task, and this is how you do that. So that's that. So hopefully this time when we run Niagara, and we run it again a second time, it cancels the first one. But just make sure that we store this. So we need to do global current task. And the reason we need to do global is because we're assigning to a global variable. So you need to do that in Python. Otherwise, it will think you're creating a new local variable called current task. So we're taking our current task, which is the same as the one up here. That's why I have to put the global keyword. And then we're going to assign it this new task that's created. So the way it's going to happen is HTTP request is going to come in. It's going to go here. It's going to cancel the previously running task if there is one. And then it's going to hand it off to here if it's a Niagara, for example. And we're going to just do our regular thing where we create a task called Niagara. Should work. Let's try it. All right, let's connect. Hello, I have missed you. Sorry about what I did to you last time. Okay, sending the new file and import main.start server. Let's go one last time. All right. So let's set it pretty low brightness. Okay, very good. Now let's set it higher brightness. Or actually, let me leave the brightness, but change something that you may be actually able to see much easier, which is, let's change the hue gap. Let's change hue gap to like very small gap, maybe 50. Aha, no more crazy flashing. So it canceled the previous task and started a new one. And now we have a totally new pattern. And so this is great. You can actually play around with this a lot. You can like change hue cycle speed, make it negative, which is really interesting. So you can make the pattern go backwards. Let's try that. Whoa. So yeah, now, I mean, I don't know if you were tracking, but now it's going upwards instead of downwards. So anyway, that's great. So that's actually working. Lastly, what we want to do is make sure that we start the server on startup so that I don't have to go into WebREPL every time that I have to unplug this, for example. So that's pretty straightforward, just right at the bottom there. Before anything happens, start server on boot up. This is all it does, just start server. That's it. We're gonna go here, and kill the code, Control C, send our final and latest main.py, and Control D. And this time I don't even need to connect to WebREPL again. That server has started. So we can try it. Let's set it. Let's change the hue gap to something much bigger. And that's fantastic. It works. Awesome. So that's everything from the computer side. Now I did promise you that I would show you how to control all this from iOS and Android. So I'm going to go ahead and do that and do some screen recordings for you to check out. Okay, so on iOS, you have this app called API Tester. And I chose this one because it's free and it doesn't have ads or any payments or anything. So you click on open that. And what you can do is you get to make like a list of requests that you would like. So you don't have to keep typing in again and again the entire thing. So for example, let's go into this HSV one. And what I've done is I put my IP address over here. And then I've put my query parameters over here, HSV. And it automatically populates those fields with that. So for example, let's change that to 80, the brightness. And let's reduce the saturation down to maybe 230. And I'm going to go to my favorite minty hue, right? And just hit play in the top right corner there. Aha, done. And you get your OK response over there, just like you did on the computer. So that's great. And you can do the same with Niagara. And you can actually store all the 5 parameters here, which is a lot more convenient than having to type it in every time. Similarly, on Android, you have this app called HTTPer. And again, it stores the IP address and the endpoint that you're hitting. Also, you can have your parameters down here. So I'm going to go ahead and, yeah, I can just send it as is, just so we can see this Niagara animation. So you hit send request at the bottom, and there you go. You get an OK response, and the LEDs are working. So there you have it. You learn how to use Microdot with asynchronous programming to make complex LED patterns callable from your phone or from your laptop. And you could use this kind of thing to build apps, to build web apps, to control your lights really any way that you want. The HTTP protocol allows you to send in your parameters as you wish. And also, if you want to build upon this even more, you can make the code more secure. Like it could actually check the values of the parameters, make sure you're not sending numbers that are out of range to protect you from crashing the code, right? So there's lots of ways to build upon this. It's really awesome. I think like having the ESP32 gives so many possibilities of connecting your project to the web and connecting it to tweets, to weather APIs, to whatever you want. You can control it exactly how you wish. I hope you enjoy this tutorial and make use of it to make awesome projects. And if you have any questions, please let me know down below. If you'd like to see more videos like this, please subscribe, either here or on my website where I explain in text all the details of all these projects. And I'm really happy to have taught this today. Thank you so much. Till next time. Bye-bye.